Hello and welcome to another episode of Tradecraft Tuesday. For those of you who have been here before with us, thank you for coming again. For anybody who's new, this is a show that we do once a month, second Tuesday of the month. And what we always try to do is break down attacker tradecraft and techniques. What are attackers doing? How are they doing it? How can you detect it? That kind of stuff to kind of give you a better idea of like, what is security? A lot of people, when I talk to them at conferences or whatever, they say, you know, security's cool, but it's like so complicated. I have no idea how any of it works. So we really try to kind of like break down that barrier and show you like, hey, here's how it works. So you can understand like what risks, am I exposed to? So before we get started, a little administrivia. If you're chatting with us in the Zoom group chat, make sure you have the little drop down where it says to. Make sure it says all panelists and attendees. That way everybody will see it. If you're like me, Zoom likes to change that and then you message random people and not everybody. So just be cautious of that. And if you have any questions that you want us to answer, so maybe we cover a topic and you're like, hey, can you talk more about this or can you expand on that? We have a Q&A feature as part of Zoom. So make sure you put your questions in there, and then that way we'll see them easier and we'll get them answered. And so, yeah, you want to get into some news here?
So I guess the root of the word news, right, is new. What is new and going down? And I've seen, I mean, every month that we do this, it's almost hard because you got to distill what are some of the most novel or unique things going down in the industry. So even though there was tons of stuff about, you know, vendor RMM bugs and things of that nature, I don't think any of that was truly new. You know, there's always vulnerabilities. There's all of that. I thought, to me, to be honest, one of the things that was most interesting, did you guys happen to catch and see like the strain of Mac ransomware was one that I thought that really blew up, not just because, you know, people do sometimes assume like, hey, it's on a Mac, it doesn't get malware, right? We all kind of know that's BS. But to me, I actually thought it was pretty interesting that it was spreading through piracy as well. To me, it just kind of reminds me of like my early days on Windows when I was playing like Grand Theft Auto 1. That was the way that it got me, right? That's actually how I started getting into malware, like as a terrible teen in the late 90s. So nice. Anyway, so, for me, I knew look, ransomware is going to happen. Finally, nowadays, there's enough traction in the Mac world where that's important. And so it was really interesting, especially for us, we're always in the situation of like trying to figure out where is the right amount of emphasis to focus on, even on our Tradecraft Tuesday content. And what was really neat to me is the installer that these hackers actually used. They started with a legitimate software called Little Snitch, which ironically, it's supposed to be a little bit of like a security awareness tool for Mac. That's how it started. And, the installer was properly signed. However, I think it was, that was just the beginning of it. Chris, did you look into any of that stuff at all before the episode?
Only a little bit to figure out like what were they using as far as like Little Snitch and stuff, but I didn't break down any of the how it worked, how they were able to sign it, all that kind of stuff.
Yeah, the long story short is the installer also contained, right? That's always but wait, there's more, right? It also contained a post-install script, which was executed. So like right after install completed, this sucker picked up and then it kicked off the rest of like making some of the shadiness. So long story short, for those that aren't aware or starting to see more and more Mac in your fleet, we obviously on our end, it's something that's keeping us up. I just posted the Malwarebytes blog, since this was probably the most comprehensive, that I also thought was pretty easy to interpret, even if you're not a rock star in security. So anyways, it's available there in chat. Obviously, if you're watching this after the show, it'll be available in the description. But yeah, for me, Mac malware. What about you guys?
I grabbed this one out of like the news feed. I don't remember where I saw it, not because Mac malware is new, right? Mac malware has been around, but a lot of people will come to us with the expectation of like, oh, I should be on Macs, right? There's no malware for Macs.
Of course.
It's just not as much, but there is malware.
Yep. Other side of it, right? This one's near and dear to mine and John's heart. A lot of folks didn't know that for a good amount of time during our offensive career, John and I did a lot with Python. The reason for the Python scripting language is even though it doesn't come natively installed on like Windows operating systems, it is natively installed on a lot of Linux operating systems. And we did a lot with the Python language, a lot for automation, its ease of use. It's kind of like PowerShell is today for Windows folks. It was just very easy to get spun up. And what's wild is, I think, John, maybe the first like time that you and I ever played in like red team, truly red team, like not intelligence related gathering, but like red teaming businesses, you and I wrote a framework that was Python based, both the Python implant that goes on the endpoint,
Yep.
and we wrote a Python backend as well to do command and control for this thing. And what was crazy is, I mean, I think that was like 2013, John, or 2014 that we did that for like the collegiate cyber defense competitions that we did that for.
Yes, I believe so.
And what's wild, John, I don't even know if you got a chance to look at this. So you and I used a tool called CX Freeze, and we would take all the Python installer and all the stuff that makes this really big and clunky and not ideal for malware, and we combine it into an archive and bring it with us. And that's how our malware ran on the endpoints. But what was interesting, guys, did you see just the rise of malware that's now Python based, that's actually attacking end users? And even though it's not the most effective and there's a lot of other things, I'm curious what you guys are thoughts on, and why in the world would people start bringing these like weird new interpreted languages that aren't natively shipping on this box to deploy malware to endpoints.
Yeah, actually, when I saw this, I was surprised, because we've seen it several times recently. We've seen Python installers. You launch it, it extracts the Python interpreter and some other files. It'll execute the script and then immediately delete itself, or it'll delete the extracted contents. And then the file remains to execute again at some point in time.
So it's funny is I noticed Mike in chat right now it said, hey, everyone starts with Python, right?
Yep.
There's, script kiddies, skids start with Python. And it's true. Like we've even seen people like on some of the dark web forums where they're like, I'm thinking about writing my own, ransomware and Python. And usually the seasoned folks are right away. They're like, do you realize how terrible that is for portability? But regardless, as we shared with this link here, it's working, it's on the rise, and it's just different enough. So anyways, two of those things combined is different. It's new. So that's what we got for you this month. So Chris, with that said, I think you're more prepared than all of us when it comes to some of the changes that have happened in MITRE. This is one of our last episodes on the MITRE attack framework before we start going into very specific tradecraft again. You want to give a little bit of background and share what we're doing and what some of the changes were that MITRE made to the attack framework since our last episode?
Yeah, so I guess this has been in beta for a little while, I guess at least since March. But just last week, MITRE updated their attack framework from version 6 to version 7. And while generally the previous updates were like, oh, we added these things, we removed this, we changed this, version 6 to 7 was a massive update where they added what they are calling sub-techniques. So when we talked about MITRE before, we talked about tactics being like, what are all the things that I'm trying to do? Persistence, execution, lateral movement. Techniques being the things under each of those categories of like, how am I going to do persistence? How am I going to do lateral movement? And really what they looked at is they said, okay, there's a bunch of stuff we have under here in techniques that are kind of similar-ish. They use a similar thing, but maybe this one is for Macs and this one is for Linux and this one is for Windows. So they took a lot of those and they made those sub-techniques. So they now have like one technique and it might have like 4 or 5 sub-techniques under it. So they can kind of group the ones that are pretty similar but slightly different. And so they use this new numbering format. Previously you'd have, for techniques, it was capital T and then 4 digits, 4 numbers. They now have that same, but they've also added like dot, 3 digits. For sub-techniques. So any sub-technique will be the main technique dot 001, 002, etc. So
yeah, I guess I could screen share. I forget, there is technology for this. So
yes,
long story short, for those of you who haven't taken a look out on MITRE's website, they've always had each one of these, columns here represents the tactic. The things below are the techniques. But if you notice now where it used to be excessive, like some of these had, especially when we did defense evasion, it's now down to 34 techniques, but this thing was, ridiculous and large. And so you see now that they've collapsed some of these into host removal. What's really neat is if you start jumping into some of these categories, like say, for instance, we're all about execution. We see there's 7 of them under command and scripting interpreter. When you dive in, it now gives you, hey, what are all the sub-technique numbers that you can link to? But you can dive down just a little bit further and see like, how does this reference, how does it relate? And, you know, dive into each one of these sub-techniques here that we just talked about.
Yep. So that's like the major change. And so a lot of things that used to be techniques are now sub-techniques. And if anybody was doing anything with like scripts or whatever to figure out what technique did this belong to, they actually created these files that they're calling crosswalk files. So they have them in both JSON and CSV. And basically what it will tell you is like, okay, the technique that was numbered, you know, T1024 is now technique 1036.002. And so it's kind of this mapping that allows you to go from like old numbers to new numbers and stuff. And because it's in like JSON, you can do it programmatically, and it makes that easier. So if anybody was working with that kind of stuff, there is that. And they got a lot more details in the blog post. I think you posted a link, right, Kyle, to the blog post?
Yeah. I threw the MITRE link in for everybody to take a peek at.
So that's pretty much it. So if you're going back and looking at old videos, we might be talking about techniques that don't exist anymore. That are now sub-techniques. There's actually still a link there where they archived the old version. So if you want to go back and look at what it looked like, it's still there. But yeah, you want to jump into execution?
Yeah, so execution's cool for many reasons, right? Obviously, a lot of us think about malware, military background. For Chris and I, we tend to think of things to the left of boom and right of boom, but execution is usually the definition of boom, right? Whether that's remote code execution for exploitation. That's the moment your end user assists and says, you know what, I do want to run that macro-enabled document. Or just something as simple as like somebody backdoored a shortcut. As we talked about earlier, the little snitch installer, somebody at that point, just by running the installer was set up to call the post-installation script that gave execution. And so MITRE calls that out as a big risk as well. And with their big risk, they had all kinds of different things that they defined this as. And we grabbed some of the ones that were most generic. Some of the feedback we got from the audience was, look, I love learning about these techniques. It turns out a lot of our audience is doing hands-on related training, whether they're watching these after the show or, you know, even during the show. And so we kind of tried to morph today a little bit into be a little bit more hands-on demo with stuff that you can learn. So guys, I'm going to share my screen real quick. Obviously, you'll see here on my screen that not only is my backdrop the MITRE ATT&CK framework and regarding the execution tactic, you and I also have some VMs set up that we're going to play around. So real quick, notice that some of these, for instance, when we're looking at techniques, talks about the command, you know, script interpreters. You see PowerShell, AppleScript, Unix script. Oh, there's good old Python. Obviously, that relates a little bit to the execution that we're talking about. And so we realized that with all of these different neat techniques, exploiting clients, inter-process communication, native APIs, we kind of wanted to show you a little bit of all of it, but it built on some real basics. So here's my ridiculous sized command prompt, and giving you a heads up, this is nothing more than a Server 2019 box that I have running in trial mode right now. It's just a cool place to learn as my test environment. And so if you see, I'm going to be using two tools. The very first one is called Procmon or Proc Explorer, and Process Explorer comes in the sysinternal suite for free. A lot of you have already probably played with this. We'll put links into where you can find this suite. But what's neat about it is it's kind of like your command prompt on steroids, right? So if we compare the two command prompts in the OS, you'll see or not command prompts, task managers. You see there's all kinds of neat relationships here where technically win init is a process. And it's the parent process to services. Well, when you're thinking about execution, especially in the context of discovery, sometimes these relationships matter. Like for instance, if you're thinking about genetic disorders, right? Something that could be wrong with me as the parent might also affect my child. Same reason that you could say, ooh, maybe a malicious parent process also spawns malicious sub-processes. And as a result, hackers try to be able to, affect this execution. They try to come up with all kinds of unique different ways to execute. And so we see here, sometimes execution can get really complex, even just in a normal environment where win init calls services, services then spawns service host, and service host spawns, many of these services that start at boot up. And that's just how that works, right? That's the idea behind services or behind processes. What's important to note, there is no concept, for instance, WMI here, services is not technically a grandparent process. Windows stops at the parent, right? It doesn't say, oh, well, here's your great grandpappy winning it process, right? It doesn't keep track of that. It's only one-to-one. And so this is unique because if you think about it, I'm in a command prompt and I run maybe the calculator. We can take a look to see what does this look like on the fly. We open the calculator and we see here under Explorer, and we'll see the calculator spawned. It's great. It doesn't show that it was spawned with the command prompt. And if we take a look a little bit here, you'll see that what truly happened is the parent process was calc, which calc, by the way, is this fancy looking calculator on Metro apps. And it said, oh, look, I realize you're running a server variant. Let me spawn Win32 calc. And that's a great example. Notice here that calc.exe is the parent process. It's more or less gone. It's broken now. The calc process is died away, and we're left with only the calculator or calc Win32 calc.exe. So anyways, that's a cool intro to how those processes work. The next piece of it, though, is you probably are asking why. And Chris, John, you and I both, obviously we play with a lot of SIM products, a lot of EDR products, and a lot of our own research trying to figure out like, where's the gaps? Do you guys want to give some context of why like that parent process and who's spawning under what context is so familiar, why I kind of set up for the next demo?
Sure. So in a lot of cases, you'll have some sort of like EDR, endpoint detection and response software, or next-gen AV that's doing behavioral analysis or something like that. And what they're gonna look for is processes that don't normally spawn other processes, spawning processes, right? It generally, when I use Word or Excel or something like that, those don't spawn other processes. They don't open command prompts. They don't run other things. So that's one of the behavioral heuristics that they're looking for is processes that don't usually start other processes, starting those processes. That's a bad thing. It's something that they trigger on.
Yeah, if you think about behavior-based detection, when we say it over and over, a lot of times people forget about like, well, what behavior? Well, who did you spawn under? What context? What user did you run with? What command line arguments did you run? John, I'm almost ready to show the Sysmon. I've gone ahead and installed the free Sysmon tool here, and I'm going to explain how that works. But John, do you want to maybe give a little bit more context on some of that indirection that we might see? And maybe one of the hard parts is just figuring out like, what can you instrument to be able to detect? Like, how are people learning what process spawned another process? And then, like I said, I'll show how that all works and comes together in Sysmon.
Oh, you're muted, John.
Overrated. We don't need those details, right?
There it goes. Okay, sorry. One of the things that we see with malware is malware will chain multiple legitimate processes together. So they'll start with, for example, WScript will start a shell process, which will then call command.exe, which will then call PowerShell. So in that chain in Process Explorer, you'll see 3 applications. And if you're only monitoring like the first or second application, you might say, oh, this is a legitimate application and let it go on. But it's actually the third one that's doing in the chain that's actually doing the malicious things. So
I want to show a little bit about the chain. So for those of you who have never heard, another free sysinternals tool that's built in, or not built in, but runs on any of the supported Microsoft operating systems is called System Monitor, or Sysmon. And so the idea behind it is Sysmon kind of works as like your own local telemetry gatherer. It runs per computer or per server, and you can make it gather all kinds of additional information. And the idea is it populates your own local event logs. And then the idea is you could take those events, pull them into some sort of orchestration system or some sort of endpoint product that looks at these events. And the idea behind it is you could maybe find a needle in the haystack. So what I've done is I've just done sysmon-i, and that'll install Sysmon. I had already run that on this server, so I didn't have to accept the end user license agreement. But if you're playing at home, you might actually have to accept EULA before you actually can run it. And what I did here is notice I've cleared out the operational log. It shows nothing. And the reason for this, I want to show you just real quick, even when I run calc just from a command prompt, take a peek at some of the logs that this is going to generate, right? So we see calc runs, that's great. But let's go take a peek under the hood of what we started seeing with Sysmon. And so Sysmon grabbed a whole bunch of useful data here. And so I'll do my best to show, and we'll notice here that from the start, we talked about calc.exe. and it said, hey, my parent process was actually process ID coming from process ID 8, command prompt, and we see it spawned the process 3036, calc.exe. And you can keep following each of these, and you'll see there's all kinds of intricacies under the hood. Remember, I mentioned that calc, the MITRE app, is going to determine, I'm parent process 3036 in this relationship, but I know that you actually want the traditional version of calc on the server 2019. So I'm going to give you the calc version instead of the MITRE version. And we get another parent process ID, and that walks you through, that's all that telemetry there. And notice when I terminated it, you can see that as well. So that's kind of drinking through your fire hose, but we want to give you that context that there is important. And the reason it's important is a lot of the examples we're going to give you today are going to be about, well, for instance, if I have excel.exe and I run a macro and excel.exe runs PowerShell, maybe that relationship of why is Excel running PowerShell is awkward and nasty. And maybe the best example to explain all this stuff real quick as we get into the examples is to share, give me 1 second, I'm gonna bring up all my lovely notes here. I'm gonna share just kind of the worst case scenario of what this can look like. And you can imagine how hard it would be to prevent something like this. And so real quick, this is one of those, like when you post something to the internet and you come back on it a year or two later, you think like, oh, I had no clue this would have been relevant. This was one of those tweets that I had posted, I think well over a year ago. And think about this real quick. If you were an antivirus or a SIM and you were trying to find out the malicious behavior. Well, let's real quick. Oh gosh, this goes all the way back to 2017 when I posted this. So command.exe was running cscript, which is a legitimate application, which is running sync appv publishing, which is running rundll32, and then eventually calling calc. Imagine if you had to figure out what malicious behavior happened in between there. Keeping in mind that everything I've run here is a signed legitimate application, right? So that's a bit of a headache. So to demonstrate this real quick and to get this kicked off of how all this crazy indirection can be used in the wild, let me show you here, going back to the same logs that we looked at before. I'm going to clear them just so we could see all this craziness and how you might find some unexpected behavior using tools like sysmon. And this is the reason that MITRE warns us so much about that it's important to monitor execution, because there's a lot going on under the hood here. So notice the command is just the same command I showed you, command.exe running all this funky stuff. We give it a run, and you'll notice even the operating system here is like, what is going on, right? It's struggling a little bit. We don't have calc right away, but we'll see it. Eventually it'll work itself out and we'll magically get our calculator. All right, just like we expected. So let's take a look, and we'll go back and forth between what sysmon saw and what we saw as users, right? Obviously, if we're humans and we're looking, you can look into every single argument here and you could probably deduce most of what's happening here. But let's be real, none of us have time to do this. This is not something we as humans can honestly analyze each command that gets run. So we have to use automation. What I want to share with you real quick is we'll take a peek at how this command here differs between what was actually happened under the hood. Right. So if we look, you know, and Chris, did you have something you want to add there? Well,
I was just going to say, we also have the benefit that they're named the right thing, right? Like I could rename cscript, I could rename that VBS script, I could rename rundll. So from a computer standpoint, they can't rely on the name because it could literally be anything. They have to rely on like, what types of thing is it doing when it runs? What system calls is it making? What files is it touching? It's very hard.
Yep. So if we take a look, I've obviously killed off calc. You could have gone here within Process Explorer and seen that if I ran it again, and it's not going to ruin anything that I'm doing right now, so I will, and you'll see that calc at the end of the day, it's spawning. We see cscript spawn. We see something. Ooh, what the hell's going on there? That's a little bit hint. What's some PowerShell going down maybe? And if we follow this a little bit more, we see some calc. And notice here, calc has no parent process other than explorer.exe. And so it's really unique if you think about that of like, if this is where you're coming in at as a system administrator trying to deduce what's going on, and you're only looking at a calc app or obviously something shady running, you might be missing a heck of a lot of context of how this even worked or how did it get here. So if we follow what that looks like, notice here, we'll see that the parent process was command.exe, once again, PID 8, and we'll see it spawned process 4268. Going to take a little bit step further, we see 4268 is another command.exe. It's now going to run cscript. So, okay, that's as expected. Keep in mind, looking at the command, all right, it ran cscript. So let's keep following here. And we'll see cscript. It's going to run sync app v publishing, but does anybody notice where things fall off the rails real quick? Like, wait, I thought I was calling C script that's going to call at the publishing of the script. Why am I now running PowerShell? And so that's one of those things under the hood, like even more specifically, look what's happening here. PowerShell is running this crazy command. So I'm curious, since we've got the group that's interactive and we got a whole bunch of questions in here, I'm going to leave this screen up. I'm going to bring my chat up here real quick. Let's talk as a group. I'm curious if anybody in the audience wants to guess where the heck did all this PowerShell come from? And notice we eventually at the very end, we see start process, run DLL, shell, execute calc here. You know, this is the benefit of watching these shows live, is you can actually participate with us and say like, yo, I know this, or school each other. So while we're waiting, guys, you guys see anything in chat we should address while we give the audience a chance to chime in?
No, not yet.
Okay. So I'm failing, by the way. I'm trying to bring up some of my chat and it's like, no, I don't want to. You know, obviously some people are sharing all kinds of other stuff. Yes, WinWord is spawning PowerShell. PowerShell is definitely a no-no event. You know, and that's what we'd think, right? PowerShell is a no-no event. And Zach, huge thanks for sharing that in the chat, right? You know, it's the VB script, and that's something Kat is sharing in here. I think it's the VB script that's kicking that off. What's beautiful here is sync app publishing VBS, right? This application here. There's both an EXE version and a VBS version of this, but what's really wild is under the hood, either one, the EXE or the VBS does, it spawns PowerShell, and its job is to actually call, and this is Microsoft behavior. So if you think about that, if you're like, I didn't expect PowerShell to run here as a child process, but Microsoft tends to call these things as helpers. And so you'll notice that it actually says, hey, I'm gonna allow this to run in a hidden window. Notice it actually imports some modules that it's going to need. But what we've done is we've used string injection. So we've given an argument, we ended that statement with a semicolon, and then we gave it a new PowerShell command and injected a new command that we knew PowerShell was being run. And so the downfall of this is anybody who is looking at the behavior of, imagine if like our chain of command at the company was John tells Chris what to do. Chris says, okay, he tells me what to do, and that's the trusted process. Think about what he did is John told Chris what to do. Someone slipped something in John's message there and has Chris do something else. And Chris goes and tells like, you know, somebody else in the hunter's team to go do what to do. And that type of injection defeats some of those behavior-based analytics. So anyways, I won't bore us anymore because we have a lot more about this episode than just to talk. But if we follow this even further, you'll see that eventually PowerShell runs, PowerShell calls run DLL 32, run DLL loads the shell 32.dll. You notice all the processes start unwinding, calc eventually calls, and then you get your end payload. So anyways, guys, way more in depth than we expected to go in here, but I hope that explainer of what process execution looks like is useful to help get us started. So does somebody want to take it from here and share some of the specific maybe techniques that fall under the execution tactic and how this kind of relates to our, you know, for our audience to understand?
Sure. So one that I pulled out here was, and we're not going to cover all of them. There's some in there that we didn't cover. We wanted to kind of cover the most interesting ones. We just don't have time to cover them all. So one that I pulled out was command and scripting interpreter, and the attack definition was adversaries may abuse command and script interpreters to execute commands, scripts, or binaries. These interfaces and languages provide ways of interacting with computer systems and are a common feature across many different platforms. And then all of these sub-techniques were things like PowerShell, AppleScript, JavaScript, Python, and then there were some other you know, lesser known things under there. So this is something we see all the time. And then so I guess, and then, you know, to John, like, why would attackers do this? Oh, you're muted again.
This is terrible. All right, I give up. I'm not going to mute it anymore. So the question was, why do attackers do this? Well, why bring your own executables, malicious executables, when you can use stuff that's built into the operating system to give you full access? You can do, PowerShell has pretty much anything, hooks into the operating system. You can start processes, you can start network connections, you can read files, you can do all sorts of things. So why make it hard? And it also makes it very easy if you write it in PowerShell to change it up really quickly. You don't have to recompile and build a new executable and push that down to your implant. You can just change your script. So one of the things that I was going to demo is something we've seen a couple times recently is using PowerShell as a reverse shell. So instead of calling in with your implant, the attacker will get on the box. We've seen this run through a scheduled task. They'll start a scheduled task that will invoke PowerShell, and instead of calling in, that PowerShell script will call out to the internet to the attacker's remote box, and they'll have full control of your system. So assuming I can get this working, since I'm having technical difficulties with everything else. Share screen, desktop 2. All right, can you see my desktop here?
Nope.
Nothing yet, Johnny.
All right. How about now? Okay.
There we go.
Cool. So I've got my trusty Windows 7 box. My Windows 10 test dummy crashed on me this morning and I couldn't revive it. So this is literally something we saw on a client machine not too long ago. This simple thing, you can see it creates some sort of socket to an IP address, does a bunch of reads, and it will, somewhere in here, send some things back and write the output. And I thought somewhere there was an execute too, but I don't see it.
There's an IEX, they execute the data. So send
Oh
back.
yes, yeah, that's what I was looking for. So it basically reads the data, it'll execute it, and then sends the output back. And so I'll show you.
So it's going to connect to somewhere, run something, and then whatever the output of that is, then it sends that back.
Yep. Sudo. Just use a simple netcat listener.
What's funny, Johnny, is a lot of people are commenting of like, hey, this template looks like something that gets dropped out of Metasploit or any of the social engineering toolkit or any of the frameworks. And the reality is there's only so many ways at the end of the day that you need to worry about having permutations. If it ain't broke, don't fix it.
Don't fix it. So did it work?
The live demo gods.
There we go. So from my Mac, I can do dir lists. I can start processes. Is it start process calc? Pop up calc, so you can send all sorts of things through this and have full control. And you do the reverse shell because typically you're blocking incoming traffic, but you're not necessarily blocking outgoing traffic. So if they put it on port 80 or 443 or something, you might not notice it unless you're using some kind of deep packet inspection. It's actually looking at the traffic to say, is this really an HTTP connection versus some regular TCP connection that looks like it's going over port 80, but it's not really HTTP traffic. So.
All while using PowerShell that is, it's a legitimate executable. It's used by a bunch of system binaries. Like you can't remove it because your system won't work if you do. So yeah, that's it's kind of interesting.
Yeah, for everybody that's on, in chat right now, Kelvin is, I guess Sir Limeslot, for those that don't know, maintains an actual, forum or a blog that talks about how to use a lot of this shady PowerShell and beneficial. So there is stuff that you can do. You can harden your system down to like constrained language modes to be able to prevent some of these functions from executing. The downfall is just like we saw from before. Hackers are abusing the trust of legitimate features that Microsoft has to depend on for their own features to be able to do it for these shady things. So like the idea of disabling sockets going out from PowerShell is just about as egregious as it gets. So you really have to look at like, what can you target without hindering productivity?
Cool. So moving on to the next technique that I put in here was native API. So this is technique 1106. And the description from the MITRE ATT&CK framework is Native APIs provide a controlled means of calling low-level OS services within the kernel, such as those involving hardware devices, memory, and processes. We see this fairly often. It's a thing that a lot of attackers do. Somebody want to talk about why they do it?
Yeah, I mean, this is something that I love just because good old Windows doesn't deprecate anything, right? It's all about backwards compatibility all the way to Windows 3.1, and almost never do they get rid of functionality. So the result is if you have all these cool tools that are doing instrumentation, remember like we saw earlier, Sysmon collecting all that data. Well, what happens if you just decide to do something in an API that your instrumentation isn't monitoring? Well, you're invisible at that point. No rootkit needed, no kernel access. You're just evading by not getting caught. And so you see a lot of this stuff. For instance, PowerShell didn't have a lot of the logging that PowerShell 4 and 5 have. So one of the techniques in PowerShell to not get caught is to downgrade or force yourself to run PowerShell 2. And as John is going to demonstrate here, that similarly, if you can downgrade to older versions, or for instance, just use the functionality under the hood that people are instrumenting, AKA native APIs, instead of Win32 APIs, you can get around a whole lot of things. So John, you want to give maybe a little bit of background on why? I think you had Covter was the one you thought would be a cool example of this one. You want to share, other than we see Covter still like every day, why was Covter ideal for this example?
Yeah, I was going to say Covter, I guess they took it down maybe a year and a half ago. It was used to click tracking.
That
That's
click
it.
fraud and
Click
ad
fraud.
baiting and
Click fraud, yeah. But they used an interesting technique. Under the hood, Covter uses the native APIs for the Windows registry, which gives you a little bit more power over what you can do with it. Typically, if you create a value within the registry, it has to be a normal string. And I'll demonstrate this in a minute, but with the native API, you can add special characters in there. And so when you create the value, the typical Windows applications like regedit can't see it, but the native API can. So I will share my screen again.
guys, believe it or not, we're 40 minutes into the episode and I'm like, you know what, I could think of about a dozen more things I want to talk about.
All right,
Yep.
So I'm going to install Covter real quick.
So it's funny, you know, just for those that are interested, a lot of people like, if you ever go down the route, especially like even as, you know, as MSPs, right, you're always trying to, you know, educate your target audience to make sure they understand the value. We obviously have to do some of that stuff as well as vendors. And even if you're not an MSP, if you're in an IT department, you have to educate, you know, the management, right? Whether it's the board or maybe it's the CIO being educated by the CISO about what is the risk, what is going on. So we use Covter for probably 2.5 years to show what was the value or why you needed something to complement your preventive software. Because like SIMs are legit, especially if you have a team large enough who can monitor a SIM around the clock. Like all of our Fortune 500 partners, they're using, you know, full on stack with a SOC monitoring a SIM. As you get further down to the SMB, it becomes like more harder logistically to be able to manage that piece. But, and then obviously that's some of the gap we were fitting. But John, you want to show, do you have Covter running on your box? It looked like you installed it.
I installed it. So here you can see I've opened up regedit. I know that Covter creates persistence in the run key, creates a couple of values typically. But right off the bat, you can see there's an error. You can't read it. If I click it again, it gives me another error. Still can't read it. But then it finally shows and there's nothing there. But because of the way Covter works, we know that there's actually something there. So we've written some tools. Let's get reg key. And I'll just cheat and use the help. I know that I'm in H key current users run key. And if we use this tool, we can actually see that there are registry values there that you can't see by default. They start with this null terminator or null character, the /x00, which is a string termination character. So normally Windows sees it and it says, oh, this is the end of a string at the end. So it knows where to stop, but because it starts at the beginning, it thinks that there's no string there. And therefore it doesn't show up in regedit.
So John, I mean, what's funny is this was technically, it's about execution, right? That was the whole MITRE ATT&CK piece that we were covering. And we were trying to think of ways to get creative about this. Like, it's one thing to see or hear about like native APIs, and there's all kinds of under the hood, these ZW functions and fancy functions that effectively exist between user space and kernel space that you could leverage for process injection or spawning another process and making it lie and spoof as it's a child of another process. There's those things you can do if you have sufficient privileges. But what's beautiful about the example that John showed is this is a 20-plus-year-old feature that was used by Malware. I mean, we're talking about like for like a 3 or 4 year period that Cubter really crushed it. The team has largely been arrested, and effectively the malware is somewhat defunct now. It's not even really operational yet. On like the daily basis, we still see Cubter every stinking day, even on systems with like awesome, like you're talking about your next generation EDR, full SIM, you'll still find Cubter. It's just that prevalent. So for anybody that was curious, like when John was clicking at that, the reason it was throwing that error once again was because regedit is written, as well as reg.exe and pretty much any other tool, it's written to use the Win32 API. But because the hackers used the native API and used a trick that would prevent a Win32 API from being able to read the data, it gave that error message that almost looks like permission errors. But the reality is it's not a permissions error at all. It's just because it's being read by an API that doesn't expect any other data. And as a result, you have to end up using a native API to be able to read and get that data. Oddly enough, John had to learn how to rewrite our agent and to support, Windows 3.1 API functionality. So super useful. And John just posted a link there about some of those crazy ZW functions. But what else do we got, guys? I mean, scheduled task was another one that obviously a lot of people think about persistence. But Chris, do you want to share a little bit about, because obviously scheduled task is one of the first ones we're covering here that MITRE has now made this subcategories too. So you want to give maybe an example or even show whether you want me to screen share, I could do that, or you can. Up to you.
Yeah, if you want to screen share.
Okay. Yeah, I'm gonna go ahead and open that up, and we'll walk through why scheduled tasks met one of our execution strategies. All right, so I've got scheduled tasks here, Chris, up and alive and well.
Cool.
In addition to it, I've got the subcategories here for you.
Great. So yeah, scheduled tasks is interesting. This kind of falls into two categories for us in the way we see it being used, in that a lot of times it's for persistence, where somebody will set a scheduled task to run every time the computer boots or every time someone logs in. But there's also other things you can do with scheduled tasks for just execution purposes, to have a parent process that's less conspicuous, to try and hide again from what we were talking about, some of those EDR tools or next gen AV tools. And the benefit is a lot of these work remotely. In a lot of cases, I can schedule something to happen 5 minutes in the future on a remote machine. So I can say like, hey, run this executable in 5 minutes, and then it will just run for me, right? Like I didn't have to go there, I didn't have to do it. So long as I had the correct privileges, I could do some of that kind of stuff. So there's a couple of different utilities. There's the @ command that works on both Linux and Windows. Those are obviously different there. And then
this is a great example of that old school, like deprecated, but still there. If I recall, I think even on the most newest versions of Server 2019, I guess I could double check here. I'm pretty sure @ still exists. John, do you know for sure?
I don't know. I'm checking I'm pretty sure I know it still exists on Windows 7.
Yeah. I got it on mine. So, I guess let me see if I can drag this VM down real quick since I'm already screen sharing, but talk about these old features that just won't die off.
Yeah, I mean,
@.exe. This command has been deprecated, but you know what? That stuff will still run.
Oh, it does say that?
Yeah.
So there is an interesting bit there, in that like the @ command can't see things created by tasks and like vice versa. I don't know how they work differently, but you can't see them. But when I was working at Red Team, the NSA Red Team back in 2008-ish timeframe, we used the Windows @ command extensively. Like we would map a share and we'd push a file over, and then we use the @ command to execute the command on the remote machine. Then we could connect to it. Like it would just basically start our back door, and then we could just connect over, and we were good. So we use that for lateral movement all over the place, mostly because their domains were set up such that like users could write to other C drives, which wasn't ideal, but So like that's an oldie but goodie, right? Like, and so you can use a lot of these to run stuff. I've seen people do like, oh, run in the future, even on the local machine, just so that we get a different parent process, like Kyle was talking about. Like, oh, what process do I want to show up as the parent process? Do I want it to show up as word.exe spawning command or spawning my evil payload, or do I want it to show up as like some other service that's executing my payload? Well, it's going to look less conspicuous if it's a service than if it's Word or Excel or something else like your browser, right? So that's one method they use here, which is, I guess, the differentiation between persistence and execution.
So I'm playing around, Chris, right now with calc to demonstrate, or not with calc, with @ to discover this, or if I could talk, @ to be able to show like what does this look like in Process Explorer to tie it all together.
Process,
yeah, but what's crazy is like obviously we're looking at scheduled tasks. The old-fashioned task scheduler. We've mentioned this before in regards to persistence, but when you're talking about creative, like not even just for persistence, but wanting it to run when other actions happen, scheduled task is ideal to give execution on really quirky things. Like some of the research we've decided not to publish just for offensive purposes is, some of these features that only run not only when like the computer plugs into power, but on how you can actually make some of these scheduled tasks not show up in the scheduled task manager at all. So even if you were looking in the UI, similar issues to what we showed with that native feature, this is now combining execution techniques, combination of abusing permissions and changing which APIs you call. You can make some of these scheduled tasks that they don't even show up in the tools that are meant to show them, but I'll be darned, they'll still run when the computer boots up. So anyways, a whole lot there to share on that side of the house. Did you have anything, Chris? I mean, obviously there's a lot you could demo. I would argue of all the things, if we're short on time, that's probably one that we could probably skip. There's a lot of it and we're only down to 10 minutes left. So,
yeah, and we've talked about that one before. I think we talked about that one in the persistence as well. So I'm sure we had demos there. I can't remember exactly. But.
Yeah. So I'm looking at, going back to our questions in chat as well. So one of the things somebody asked said, hey, could things be tied to the, print spooler service? What's beautiful is there's numerous exploits. One of the ones, like we didn't even really cover WMI, guys, did we? But one of the things that we could, we could jump back into WMI, is the idea of Windows has a management infrastructure or instrumentation under the hood. It's built into Windows, and most people are just used to querying this instrumentation to be able to get data back. But one of the big questions is, well, what could you do? Could you make something execute as WMI? So I guess maybe that's ideal to start there, Chris, and then I'll answer that print spooler question at the end.
Sure. Yeah, it's I don't know why WMI has this functionality, but with WMI, you can basically tell it to create a process and it will. I'm not exactly sure what the point of that is, but they've got other stuff in there that people have abused for persistence and for executing things like command line. What are those called, John? Command line event.
Consumers.
Consumers. There you go. I can remember that last word. And it basically like looks for like somebody running a command line. It's like, oh, okay, I'm gonna run this. So it allows them to get triggered when something happens, and they can run their own payload, and it runs as like somebody else, and it looks less inconspicuous. So I guess all of this kind of goes back to what we started about talking at the top of the show, which was attackers are looking to execute stuff. They're looking to look as unambiguous as possible. They want to blend in the best they can, and they're going to use a bunch of techniques to do that, to try and look like system processes or look like they're a child process of a system process, all that kind of good stuff.
John, since we're, we got a bit of an audience here that's hanging with us, any chance you happen to have any of the examples of using WMIC or the WMIC command, like any malware there? Because if so, I don't even mind trying to like run one of these darn things and showing like what Sysmon has. I know that's off the cuff, so don't worry if you don't have one.
I do have a example we saw, I think it was late last year. Somebody used WMIC with create process to run ransomware across a whole network. They scripted the command to push all the files to each host, and then they used another batch file to run in succession WMIC on each computer, because WMIC has the ability to run commands remotely. So they passed the username and password on the command line and told it what X command to run. I can do a screen share real quick and show you that.
Yeah, either way, John. And while you're getting that, are you ready to screen share now, John, or you want me to pick up?
I can screen share now.
Go ahead.
Is it shared now?
Yep.
Okay. Let me change the view so it wraps, make it a little bit easier. Here in this case, there were 2 batch files. This is the one that they started with. They just went through a list of IP addresses. In this case, it was all these internal IP addresses, and used Xcopy to copy files to the remote admin shares on each box. And then they executed this second script, oops, wrapped again, which did the same thing. It looped through each address and then ran WMIC against the computer, specifying the username and password, and called process call create command.exe, and then the batch file that did the encryption.
That's wild, John. I'm gonna go ahead then. If you stop sharing real quick, since we started off the top of this episode showing a little bit about instrumentation, I'm gonna go ahead and clear out my sysmon logs, and I'm going to run that exact same command that you just had in that malware, which was nothing more than what it was, a WMIC process call create. Is that correct?
Yep. WMIC process call create, and then they with command.exe and then /c, and then you could specify whatever you wanted to.
All right, here I go. I'm screen sharing. So real quick, just to make sure everybody's still on the same page, we still got Proc Explorer running. I'll go ahead and kill off some calc.exe so we don't have any confusion here going on. So we see calc goes away. We see my process list, and we see our event logs are pretty much naked here. So I'm going to do nothing more than from that administrative command prompt, I'm going to call WMIC, let it do its thing. You'll see that, hey, it decides it runs, it gets back the process ID, and it gets back the return value. So that's neat here. That's a great example of WMIC bringing back some of that instrumentation to tell you what it did. And under the hood, you could see it's calling the Win32 API process create. But what we take a look at is if we go and refresh our sysmon logs, we should see a little bit of history. We should see, all right, here's where WMIC's going to kick off, and it decides, you know what, we're going to run command.exe. And we see that it even says like, oh, I can't determine the publisher. So that's great that it's bringing back some of that data on the extended validation certificate. We'll see a little bit more here. We'll see calc.exe spawns. And what's interesting is you start wondering like, well, what the heck is it running under this context? But just a little bit more poking, you'll see that like, oh, hey, WMIC ran. And it turns out that, you know, the event originated on another computer is what it's asking. If it did, you can display more information. But notice how complex it gets real quick as you just try to figure out like, where did this come from? And once again, calc then calls WinCalc32, right? Showing that once again, parent process of calc said, oh, you're expecting the GUI version of it. Let me give that to you. And if we go back, once again, we're at calc32. But if we inspect this, even when we look, its parent process is non-existent, right? So it's not aware that calc.exe even existed, let alone WMIC was used to spawn it, let alone WMIC happened within the command prompt. So all those things, I hope this is useful to see how these subtle little things start tying together when you're trying to form the picture of what event happened at what time and why monitoring these relationships is important, but also understanding that these things, just like anything, can be bypassed. So guys, I know we had some honorable mentions that we wanted to cover. I know we didn't hit all the content we wanted to do, but we're right at about an hour. So who wants to take maybe the first honorable mention?
Oh, I said this one, the user execution. This is likely how malware gets in the first place. Somebody gets social engineered, hey, click this link or download this PDF of resume and open it up, and then that's the initial execution that they get in through users.
Yeah. So user execution, obviously you can, your honorable mention doesn't have to be the most elegant. It can be good old fashioned, just how to, convince the users to do something shady. What about you, Chris? You got anything there?
I also put in here software deployment tools. We've seen a lot of partners and MSPs get wrecked through their RMMs. There was an issue that we talked about last year with Webroot, where if you were able to get in the Webroot console, you could just run a command on every single host that existed. All of these kinds of third-party softwares that allow you to install tools and remotely manage machines, well, attackers can use them as well. And so I figured we'd throw this in here just as like, hey, FYI, like this is still here. This is how you can get execution.
No, I mean, that's a great example. So we've got several folks in the MSP community here on our chat with us, right? And if I think about all the different crazy things, right, we weren't just going to sit back here and relax, hang out in our jacuzzi. We were going to specifically try to make sure that we had, something to end this with a bang. So recently, Automate had a vulnerability. And yeah, Mike already called it. He said, ConnectWise Automate. And it had a vulnerability that involves some execution. It was SQL injection. So I figured, why not, since now that vulnerability is patched, we could share a little bit more about maybe what was happening under the hood when execution. And so if we take a look, like a lot of us forget that those agents that send data when we deploy any RMM, not specific to ConnectWise, any RMM, it's sending data to a backend. And if that backend is parsing that data from the agent, it has to assume that that data could be malicious input, or it has to guarantee, like through certificate pinning or some type of mechanism signing, that data hasn't been tampered with. That is critical. And for us coming from a background in intelligence gathering, I can tell you that is a big concern. Well, it turns out that some of the issues that were happening was when your agents were sending, if you could get an agent registered, if you had your agent running on an endpoint, or you could spoof being an agent and talk to the back end, you could possibly do injection. So for instance, one of the vulnerabilities that caught news, and I believe this was Jesse Connor's bug that he had patched here on the agent side, Jason Slagle, who helped patch some bugs in the probe side of the house. But where I'm going on this side of the house is take a look at just the simple process command send monitor trending data function, right? So it gets in some data, whatever it gets in from monitor ID, it stores it as a string. And if we take a look, they sanitize that string by casting it to an integer. So that means even if it had malicious text in there, they're trying to change it into a number. So that way that number can't be used for part of injection because they're not going to use it that way. And think about it, if it has malicious commands that can't be casted to a number, this would blow up and it would get caught in the try except catch there. But notice here num that it gets used. They then accidentally here with text, they instead use the text from monitor ID and they don't use this number, thus allowing a hacker that when they do the string concatenation to be able to input, just like how we did some of that injection of into, I guess it was the syncAppV process earlier where we got PowerShell to run our other command to call other stuff. This same type of injection works where if you could influence the text that comes in from the monitor ID, theoretically, you could make the SQL statement run straight in your database as root, and it would run that way. And anyway, so maybe that's a great way to go out with a bang. When it comes to execution, there's all kinds of different shapes and sizes of where execution might come into it. And I hope that was a little bit more of a cool way to end with a bang on how does that relate to all of us, that execution comes in all shapes and sizes. So Chris, you're always the guy who opens this up. You want to take us home with maybe offer anybody with some Q&A, throw some places where people can find us while we're giving people a chance to ask some of those questions?
Yeah, I think Jason was trying to ask a question in the Q&A, but the whole thing didn't come through. I just got hi guys. So
yep. I did get one. Somebody asked how to get access to the recording was his other part of his question.
Yes. Oh, that was him as well. Okay, so I replied to that one. Basically, we're going to post these to Twitter, or not to Twitter, to YouTube about a day or two after we record them, which is why we were talking earlier. We keep getting these strikes because apparently we're teaching people how to hack or something. Whatever. So yeah, so I think that'll happen within the next day or two. If you have any additional comments or questions after this, anything that you think that we should talk about, like maybe you find some topic and you're like, hey, that's really interesting. I'd love to see a Tradecraft Tuesday episode on that. Hit us up, tradecrafttuesday@huntress.com. You can send us an email there. Other than that, we got some upcoming events. Tomorrow, we got a Huntress product demo webinar. So we hear from a lot of people who say, hey, I joined the Tradecraft Tuesday and you didn't tell me anything about Huntress or what it does or how it's going to protect me. Well,
that's how it's supposed to work.
Yeah, we tried to make this just educational. Show up, we'll tell you about some stuff. It's not a product pitch. It's not a vendor pitch. Come here to learn stuff. If you want to know about Huntress, though, join this product webinar tomorrow. And we will drop links here in the chat. Day after that, let's see, today is Tuesday, Wednesday. So on Thursday, we're going to have SMB Tech Fest. Is a virtual event. We're going to be there. So if you haven't signed up for that and you'd like to come talk to us, talk to our reps, find out more about Huntress, you can find us there. And then on July 28th, we're doing a joint webinar with ID Agent. We're going to talk about cybercrime markets, what we see there. We've got a lot of interest from people who have seen our stuff before, where Kyle will go on the dark web, pull out some stuff, talk about what are all these attackers doing, how do they work together, how have they created these businesses for, you know, sharing credentials or, you know, sharing like, oh, I have access to these machines. So if you're interested in that kind of stuff, you like that, join us for that ID Agent webinar.
Cool, cool. So I know everybody's, digging my little flying background and canaries and everything else like that. Appreciate that. For those of you that have no clue what we're talking about, it's related to a Huntress service. We'll keep that to the pitch tomorrow. But I will thank everybody. Obviously, it's not easy to come out for an hour once a month, but a huge thanks for everybody for joining us. I will encourage, if anybody has any questions, support@huntress.com. Hit us up with like what you want to see at Tradecraft Tuesday. We're doing MITRE ATT&CK framework because someone mentioned it months ago. We've got some other ideas, but to be honest, we want to know, what do you want to learn? What can your team benefit most from in this 1 hour of training a month that we can allocate time to write content for? So huge thanks everybody for joining us. Huge thanks for the ideas, and hope you enjoyed, I guess, our July episode of Tradecraft Tuesday.
Yep. All right. See ya.
Take care.